This is a lesson on rate of a chemical reaction. This is part of the Year 9 science course in the chemical world topic. So a chemical reaction is basically the rearrangement of atoms. So you take some atoms of some elements. Okay, suppose I've got some element that's got atoms that look like this, and I add them to atoms of some other element that look like this, so two different elements, I'll get something else which looks like this. Okay, for example. Okay, it's simply things coming together to form something else. So suppose I have element X represented by the white dots and element Y represented by the black dots, the shaded in dots. I'll get something like this, X and Y together. So I haven't made anything new. I've just simply taken from the initial materials, the initial elements, and rearranged them, reorganized them into something else, okay? This is called the law of conservation of energy. And, law of conservation of mass in this case. So in other words, mass isn't destroyed or created, it's just simply rearranged. But for the upcoming assessment that you have, you just need to know that a chemical reaction is simply the rearrangement of atoms. So atoms reorganizing themselves. Now you can actually speed up or decrease the rate of a reaction, the rate of a chemical reaction. A better way to say this is the speed at which chemical reactions occur is called the rate of reaction. So rate of reaction just means the speed of a reaction, how fast a reaction is going to happen, how fast this reaction at the top here, this example, is going to happen. Okay, and there's several ways, so we're interested in ways that you can increase the rate of reaction. And there's 5 different ways that you can speed up a chemical reaction that you need to know of. The first way to speed up a chemical reaction is to increase the temperature. So temperature. And I told my students in class today that this is something that's from intuition, from common sense. Suppose I've got a cup of boiling water and I've got another cup of really cold water. The cup of boiling water indicates a faster reaction because the particles, the molecules, the water molecules in this case, are moving faster. So temperature is basically a measure of the kinetic energy. Kinetic energy is moving energy. The kinetic energy of particles. So the more energy a particle has, that equates to higher temperature. That's what temperature is. Think back to the cup of boiling water. It's hot. It's hot because the water molecules, if I draw each molecule like this by a circle, even though it's not, but anyway, for argument's sake, and I'll draw dashes, the dashes indicate that they're vibrating, that they're moving a lot faster than, let's suppose, the water in the water molecules in the cold cup of water. Okay, so less dashes. So if you increase the temperature of a chemical reaction, there's more kinetic energy in the molecules, and hence there's more collisions between the molecules. More collisions means they're moving faster, and therefore you've got a faster reaction rate. So more, I should say higher temperature, higher T, higher temperature equals more collisions, which equals higher, I should say, faster reaction. Okay, so that's one way to increase the rate of a reaction. Just increase the temperature. Second way to increase the rate of reaction is to increase the concentration of a substance. Concentration is basically how much stuff, how many reactants, I should say, how much stuff there is in a volume. Suppose I have a cup, a beaker. Okay, the volume is basically a cylinder. It's basically how many particles I have, how many molecules of anything I've got initially. Okay, reactance means things at the start. Okay, they react. That's where the word reaction comes from. Two things react together, reactants, react together to form something else. Things at the start. So things, in this case, are molecules. They could be atoms by themselves, could be other particles. And if you have more concentration, or I should say higher concentration, that equates to more stuff, more particles in a volume. And if there's more particles in a volume, more stuff, that means there's more collisions. Think about a room full of people, let's say 10 people. If I keep putting more people into the room, there's going to be more collisions between people. People will start bumping into each other more, right? That's concentration. Okay, it's basically how much stuff there is in a particular volume. So more collisions, which equals faster reaction, quite simply. So I'll draw a diagram here. I've got two beakers, two cups, one with a particular element, and let's suppose the element is white in this case. Element X could be anything, doesn't matter. And I'll draw another beaker, and it looks like this. This second beaker here with the element X, let's say, has a higher concentration. The third way to increase the rate of reaction is quite simply just stirring the reaction. It's called agitation. Agitation means stirring. If you stir, there's more collisions. So just to note, with all these ways to increase the rate of reaction, they all involve more collisions. If there's more collisions, there's more reaction happening and the reaction happens faster. More collisions, faster reaction. This is an easy one to picture. Suppose I have a cup of Milo powder and milk. So the powder's at the top, let's say, typically. Some at the bottom, but anyway. Milo in a cup. If I get a spoon and stir it, it's going to be easier. It's going to taste better than it is if you don't stir it, because it's now a mixture. Once you've stirred it, the Milo particles have reacted with the milk, and there's now a reaction, and you get a mixture. Okay, and the reactants, the Milo in this case, reacting with the milk, ends up giving you a mixture. And when you stir it, there's more collisions. More collisions means you get a faster reaction. Then as opposed to if it was just Milo in a cup of milk, it's just going to sit there. Okay, unless you wait for a long time, the Milo may just mix with the milk and you'll get the mixture. But stirring, agitation, is quite an easy way to speed up a reaction. Number 4, surface area. If you increase the surface area of the reactants, you have more particles exposed basically. So increasing surface area exposes more reactants. I'll show you in just a sec what that means. Suppose I have a reactant in the form of a cube. Let's say I've got sodium metal. If I cut that sodium up, if I slice it, I'll have the cube, okay, a smaller cube, because I've cut it up, I should say thinner, smaller cube, plus a slice. This has greater surface area than this, because I've got more particles exposed, okay? So more particles means more collisions. Suppose I was going to react this sodium with water. Okay, I would want this second scenario here because there's more particles that are going to react with the water. So more collisions, which equals faster reaction. So that's number 4. Number 5, the fifth way and final way to increase a chemical reaction is to use a catalyst. A catalyst is just a fancy way of saying chemical. So it's a chemical which speeds up a reaction but doesn't get used up. So it's like a spectator. It just goes in, let's suppose it's it's a special forces officer, goes into a room, does what they need to do, and then gets back out, okay? So that's a catalyst. E.g., your saliva. Your saliva has a catalyst, it's called amylase. Okay, and the catalyst in your saliva is designed to sort of help the food sort of break up a bit so it can be digestible a lot better. So, and catalysts, what they do is they reduce the amount of energy you need. They reduce the amount of energy you need to turn the reactants, what you have at the start, into something else. Okay, the product in this case. So if you're reducing the amount of energy, the reaction is more efficient and the process takes less time. If it takes less time, that's a faster reaction. Okay, catalysts. So to summarize, there's 5 ways to increase the rate of a chemical reaction. The first way I talked about was increasing the temperature, which is just increasing the kinetic energy, the moving energy of the particles. If there's more movement, there's more collisions, and then there's more reaction, faster reaction. Second way is by increasing the concentration of a substance. So if I add more stuff into a volume, there's more collisions and there's a faster reaction there. The third way is by stirring, agitation. If I stir stuff, there's going to be more collisions and hence there'll be a faster reaction. Number 4, surface area. If I cut something up into pieces, it's going to react a lot quicker because there's more stuff that's exposed. Okay. You can also think of the tablet, dissolvable tablet in water. If I cut up the tablet, break it up, it'll dissolve faster in water than if I don't break it up. And the 5th and final way that I mentioned is the use of a catalyst. And it's just a fancy way of saying a chemical which helps speed up the rate of a reaction. It doesn't get used up in the reaction and it basically reduces the amount of energy you need for a reaction. So it happens quicker and more efficiently.